side injection test rig consists out of a tube where the arrow wedge sits inside, and there's 2 pressure vessels that are mounted to the sides of that, so we can inject gas onto that wedge. In this particular case, this is all static, so we're not having that projectile be in motion. However, we can correlate this data to our simulation data to see how much force actually gets translated into thrust.
45. We're holding for a minute, so just continue to regulate. Give us a countdown.
3, 2, 1.
We're here to crack the solar system open like an egg. We're building a multi-injection kinetic accelerator for taking large stuff to extremely high speeds and putting it directly into orbit.
The side injection test rig was a really exciting test rig to set up, just because most of the time in aerospace engineering, when you're dealing with hypersonic flow, it's a situation that takes place over a longer duration than what we're talking about here. In our case, we're not only dealing with hypersonic turbulent flow, but we're dealing with hypersonic turbulent flow in a microscopic timescale. I mean, these things happen in sub-millisecond timescales. So there's a lot of lack of literature when it comes to like actual data from this kind of setup. We are doing cutting edge technology in a shipping container. It's pretty fascinating to work on. So the static test rig and side injection only gets us so far. When things are accelerating, the forces that are seen and the forces and momentum transfers that are observed, they're very, very different than a static setup. So while this static setup shows us kind of a best case scenario, and it shows us a lot about verifying our CFD, verifying our analysis with pressure maps, it doesn't tell us much about how well the accelerator performs with a projectile that is in motion. So while this test is being set up and tests are proceeding with this, we're also building out our 6-inch accelerator, which now will have side injection sections. So as the projectile is moving down the accelerator, we will be measuring acceleration on the projectile and see how the side injection either confirms or doesn't confirm the data we're getting off of the static test rig.
See, there's a projectile in there. We're going to inject gas into this wedge. Those side injector vessels is what Peter is currently working on together with Will. So they're welding up the vessels, and then they're going to weld the flanges to the branches, and then eventually when we get there we'll cut the holes into the barrel and then attach all the side injectors to the barrel. And then once we're there, we're going to shoot a projectile and we're going to accelerate it using side injection.
Right now we've finished welding most of these boosters together. So there's a flange with a gas cylinder, and then we're going to hook these up to hydro test them outside. They're pressure vessels, so they need to have a tested with a safety factor 1.5 times our actual use. So we're going to be testing these to 1300 psi. We use them at 850. And over here we're welding a few remaining ones together. I've done a lot of welding that's required to be watertight, but welding pressure vessels has been new and they have all worked. I've not had leaks, which is great. Proud of that. Creative problem solving is probably my #1 favorite thing. So doing design reviews, trying to figure out some small feature in the design that might help unlock new possibilities, that's probably my favorite thing.
It's pretty exciting to actually see the hardware hit the road for the first time.
Yeah, this will be the first time that we're accelerating payloads with side injection. You know, we have a history of shooting the system and we've accelerated payloads from behind like a normal artillery type piece, but this will be the first time that anybody ever has accelerated a payload by injecting onto a wedge like this. That's gonna be truly groundbreaking for us and really show that, hey, like there's the future for this type of technology.